where did we stop on Tuesday? We stopped at here in the middle of page. In the middle of page. In the middle of page 16. Okay. Now remember that we have the first quiz next Thursday. Okay. Now it will come from pages 5 to 16. So today we will go from here. Now as I've mentioned, as I've told you last time that often we have 2 points M and N, and we want to, and we know that, and we have coordinates of M and N, and we know the line of action of F goes through M and N, which means that the direction of F is equal to the direction of MN. Okay, and so how do we get the direction? The vector of F in this case. Now, if we write down coordinates of M and N in brackets, and remember that for this bracket, that we can only use this for coordinates, but not for forces. If you write your answers as forces, then remember to write it as I in terms of I, J, and K. Okay. Now, in terms of I, J, and K. Now, of course, we can write down the vector MN, right? If we can write down the vector MN, and at the same time, we can write down the length of MN. MN is equal to x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared, right? And now we let the length of MN as d. This should not be a problem to you. I think you can do this, right? And it's okay. So from here we write MN. MN is equal to d times x2 minus x1 di plus y2 minus y1 over dj plus z2 minus z1 over dk. Right? I will say this is equation A. I will say this is equation A. So I think you know how these are the same, right? These two are the same. It's okay. Yeah, okay, good. And we know what D is. Now, so on the left hand side, So on the left hand side, the magnitude. So we write down the magnitudes. Okay. The magnitude of Mn is D. The magnitude of D is of course D, and what's the magnitude of this? This part. What's the magnitude of this part? On the left hand side, we have the magnitude is D. This one is equal to D. The magnitude of this is equal to 1. So this is a unit vector. So this is a unit vector in direction of Mn. Okay, so this is on page 15. Okay. So we talked about this on Tuesday. So and from here we say we compare two things. We compare this one and we compare equation on page 15. I'll come back. And we compare this one, 2.21, and this one. Okay. Compare A with 2.21. Remember this on page 15. And so we have cosine theta x equals to x2 minus x1 over d. Cosine theta y is equal to y2 minus y1 over d. And cosine theta z is equal to z2 minus z1 over d. This is what we want, and we will use this. It's okay. What do we call this? What's the name of these three things? Anyone remember? These are cosines, so these are called direction cosines. Okay. So remember we have testing. Now, I think I time to write it down. And if you have written this down, then think about a problem of English. So I think you have learned this one called 介词 or the preposition. So usually if we say compare A, and I write here, compare A with 2.21. So we can write with here and are there any preposition that we can use here? And for those online, that you can also leave your answer on the discussion board. And of course, we say compare A with B. Compare A with equation 2.21. But do you have other answers here from your English class? Any answer? Compare. I write compare A with B here. But have you heard or do you know if or do you think there are any other answers? Compare A. Have you heard about this? Have you heard of compare A to B? Sorry, I should use another color. Have you heard about? Oh, very good. Compare A to B. Have you heard about it? Have you seen this? Compare A to B. So, and so we are here compare A with B and compare A to B. So is this? So of course I would say this one is correct, but it is wrong, or is it correct? Or you have another answer?有见过吗？我们去看那个硬件的好不好 ？So is this correct or is it wrong? Or the answer is like this. So actually, and compare A with B and compare A to B have different meanings now. So I write it more clearly. Compare A with B is it is we say what is the same between A and B and what's the difference between A and B. And if we say compare A to B means in Chinese in Chinese the meaning is if you say compare A to B, that means you are saying what's the same between A and B and what's the difference between A and B, and you mean A and B are similar. Okay. Is okay. So usually in engineering, usually that writing down mathematics, that usually we will simply say compare with B most of the time. Usually we simply say compare with B. Okay. Now, and if we just take your time to write it down, and after you have written this down, we go directly to page 18. We go to page 18 directly. And who hasn't got this? Now, and we will skip. We will go directly. We'll go to page 18. Okay. If after you finish running it. And for page 17, I don't have because of time limits. I don't have time to talk about this. And this is simply this is the only points to. I'll go to page 18 directly. Okay. So here is a sample problem. We have 200 kg cylinder, and it's count, and this is hanging, or the original verb is hang. Okay, by means of two cables A, B, and AC, and these are attached to a vertical wall. Horizontal P is also cylinder position, and we determine the magnitude of P and tension in each cable. So we need to determine magnitude of P and tension in each cable. So you need to calculate tension in AB and tension in AC and P. These three quantities. Okay, these three bits. Also, we need to calculate. We need to determine P. We need to determine this force, and we need to determine this force. Okay. So before each is I assume you know. Now because of course in the question that P is marked on the diagram, so you don't need to need less P, but because we don't have it only says tension in this cable and tension in this cable. So first of all, to begin with, so we let TB and TC be the tensions in cables AB and AC respectively. Respectively. Now, before we do calculations, what should we do? Free body diagram, okay? So we draw a free body diagram. And before we draw the free body diagram, and I want to ask how many forces are there in the free body diagram? Of course, that we need to determine P. This is the first one, and then we need to determine the tensions in two cables. So at least there are three forces. How many forces do we have in this problem? 1, 2, 3, 4, 5, 6, 7. How many? Of course, at least we have 3, right? So we have P, we have TB, and we have TC here. Anything else? So this is also we have the weight of the cylinder. Okay. So it is 200 kilogram. And so here actually we have 4. Okay. Remember we have 4 forces. So we have point A here, point A here, and then we have P, and we don't know the magnitude, and we know, and also we have TB and TC, and we don't know the magnitudes either. TB and TC. Okay, and we have the weights, but we know the weights, right? And the weight is equal to 200 kilogram weight. I usually write 200 kilogram force, and which is equal to this number. Remember, in the of course, in your high school physics, that your teacher would ask you to use 10 as the vector, g equal 10. But in the engineering, we usually use g equal to 9.81. Okay, we get 1962. It's okay. Now, of course, we know the direction of W and we know the direction of P. But if we calculate equilibrium, but we need to know the direction of these two, right? What do we know about the directions of these two? TB is in the direction of AB, and TC is in the direction of AC. Okay, so we simply use the method on the last page on page 16, and we will write we will go through the SOP and once. So we have AB is equal to how much? If we go from A to B, so in the x direction, it goes from 1.2 to 0. So this is minus 1.2 meter I. And in the y direction, we have from 2 to 12. So can you see it? Okay. Yeah, the coordinates of A, B, and C are given here. So given on the top right hand corner here. So in the x direction, that we go from A to B. Remember that if it is negative, just write it as negative. So from going from A to B, then from 1.2 to 0, we have minus 1.2. And in the y direction, we have go from 2 to 12, so we have 10 meter J. And then from in the z direction, we have 8 meter K. Remember this thing, huh? So if it is negative, write it down as negative. And AB is equal to, the length of AB is 12.86 meter. It's okay. And it's okay. Next we have AC. Using the same method, that is 1.2 go to 0, that is minus 1.2. And this is 10 meter J. And here we go from 0 meter to minus 10 meter. So this one is minus 10 meter K. And the length of AC is 14.19 meter. Here, just take your time to write it down and so from here you can write down of lambda AP and lambda AC using the steps on page 16. So I was I will leave this as your homework and but AC is given to the part of AC is given to you. So using the procedure, and we have these three. Okay. Why do we need to get the unit vector of AP and AC? Because these three are, what are these three? Direction, cosine, good. This one is cosine theta x. This one is cosine theta y, and this one is cosine theta z. And we will use them later. You can write it down and okay, so after you have marked this down, we go to the next page. After we know the directions, then we can calculate the equilibrium of system. Of course, that if I see your table, of course, when I in the exam, I know you want to calculate equilibrium, but please write it down. What are you calculating? That means please write it down. Please write this down. Summation equals f equal to 0 is equal to TB plus TC plus P plus W. Okay. This is for you to protect yourself in examination. Now we have this one, and we have in same as 2D, we simply write a table for 3D, and so if you forget this, and it is on notes page 11, and here we write down a T, B plus TB, TC, P, and W. And we don't know PB, we don't know PC, and we don't know P either. But we know W. W is 1,962 Newton. And because we are adding all forces together, and summation F equals to 0. For those online that do have any problems, and if you're okay, please hit the hands up button, please. Okay, thank you. You may put your hands down. Now, so after this step, we will write. We are just filling this table, and I will leave this for you to do it at home. But of course, you can. And of course, the answers are listed below. No? Now, here in the x direction, we have on the TB we have negative 1.2 over 12.86 TB. Let me make it a bit bigger. Okay. And on TC, we have minus 1.2 over 14.19 TC. And on P, because P is in the positive x direction, so we have plus P. And for W, because this is in minus y direction, so we have 0. Actually, minus W is here. And because of equilibrium, and we have 0 here. Is that okay? So I find the logic. These two come. This one comes from cosine theta x. Okay. Remember, if it is negative, then write it down as negative. For some of your seniors, the biggest problem was that in direction cosine, I see the minus sign, but in the table that they forget to put the minus sign in, so the answer will be wrong. It's okay. Remember that it's a negative sign here. And so I've done the x direction for you. So when you go home, please do the y and z directions. So because we have 3 equations and we write down these, I can't be smaller. And so we have these 3 equations. When you write these 3 equations, I have a question. If we write these 3 equations, do we need to put anything in the front? Yes. Then, if yes, what are those? What should we write in the front? What should we write here? Remember to write summation fx equal to 0, summation fy equal to 0, and summation fz equal to 0. Okay. In the quiz or in the examination, remember to write this down. Summation fx equal to 0, summation fy equal to 0, and summation fz equal to 0. And from here, you can use, you either use by hand, you can solve the equations by hand or use a calculator. And we have TB equals to, let me write the answer down here, and We don't need to write. We don't need to write. Sorry, I'm only writing that. So these are the answers. And can you please check it for me at home? And if you have any problem, that if you get different answers, let me know on Tuesday. So, and what because I did not write down everything, so please, when you go home, that fill in the blanks and to write all these things down and you know. So it's okay. So before we end, I want to talk a bit about chapter 3. Of course, I will go on to chapter 3 on Tuesday. Chapter 3, rigid bodies, and so the difference between there is a difference between chapters 2 and 3. In chapter 2, we talk about sorry. In chapter 2 and chapter 3. And chapter 2, we talk about forces on points. And now, from next week on, we are talking about forces on rigid bodies. Rigid bodies in Chinese is this one. So these are no longer points. We are talking about one thing. Okay. So what is the difference between forces on points and forces on rigid bodies? The difference is there is no rotation. We will say there is no rotation on those points. But from next week on, the rigid bodies, after we put forces on them, then we have we need to calculate the rotation. Okay. So it seems that things are quite different. So now, what is a rigid body? So it is if you don't want to write it down, that it is on page 84 of textbook paragraph 2. So a rigid body is a body which does not deform under external forces. Deform means this one. So I'll write it down and I will make some remarks afterwards.